All right. So the next one we have is Ben Bridts. Ben, are you in here? I see him. I'm going to bring him in. Ben, what's up?
Hi everyone, how are you doing?
Oh, I like your shirt.
Thanks. I like yours too, although it's a little bit hidden.
Yeah. I need to get. Yeah, here it's the Sam plus. Yeah, there you go. Very cool. So, Ben, what are you going to be talking about today?
I'm going to be talking about all the things I did wrong when I wrote Instactors code,
If it
especially
helps,
focused on. Sorry.
if it helps you, I have a list of things you've done wrong. So that's up to you. All right. Well, I'm going to turn it over to you. I'm going to drop out. Nicole, you doing all right? See, all right. We got the salute and the thumbs up. So, okay, here we go. I'm going to drop out and I'm going to bring your screen in. And good luck, sir.
Perfect. Thank you. So, thank you, Eric. Hello, everyone. My name is Ben. I work for a company called Cloudar, and I also have some stories to tell. I'm mostly here because I made a lot of mistakes. And I don't mean that giving this talk is a mistake, but I've been writing infrastructure code for 6 years and a bit now, with a lot of different tools, CloudFormation and things that generate CloudFormation, like Troposphere and the toolset around that, even before CDK was a thing. And in those 6 years, I had the chance to make a lot of mistakes. And if there's one thing that's better than learning from your own mistakes, it's being able to learn from somebody else's mistakes. So I'm going to try to tell some of those things that went wrong when I tried things. I have to mention a few things before I get started. All of these are actual real examples of mistakes that actually happened, but I recreated them all with CDK code. So that means that one, I had to simplify it a bit so it would fit in on the slide and you wouldn't have to like get a magnifying glass just to read the code. So if your first reaction to something that I put on the screen is, why would you do it that way? It's probably because some context is missing. But feel free to ask a question. After the talk, we will have 10 minutes for questions and we can go into that. Secondly, every mistake that I will show and I will talk about is one that I made. I'm not trying to throw any shade at anyone, so if this seems like something that's familiar to you, something that you might have done, I'm sorry, it happens to the best of us apparently, but I'm not trying to single anyone out. And thirdly, I'm going to be saying we and I a lot. If I say we and it's about something good, it's definitely something that we did as a team. If I say we and it's something bad, I should have said I, and I'm sorry for that. So that being said, let me tell you about some of the things that I actually wouldn't do again. And the first example that I'm going to be looking at is a migration that happened. So we had a lot of servers that had to move to AWS. It was going to be mostly a lift and shift migration. So we needed to be setting up a lot of EC2 servers. And there was a strict deadline. So we decided we're going to make it as easy as possible for every team that needs their own servers. So they can start as soon as possible, move as much as possible to the cloud before we hit that deadline. And we might want to make that possible even if they don't have a lot of AWS experience. So we decided we need something like this, where every team should be able to define their own stack, put a list of instances in there, and then we would have some code, in the CDK case, a construct that would take care of all the details. And the details would be putting, starting the instance, putting everything on there, having alarms and monitoring around that, making sure that integrates with all the other tools that were already being used. And the only thing that the team would have to put in is names. Because we're using, in this case, configuration management software. So the moment that an instance would start, there would be some software on there that would fetch the name, see, oh, this one is an app server, and then install the right thing on there. If it's a web server, install Nginx. If it's an app server, install Tomcat, for example, things like that. So we created our construct called instance group. The my server's name here is arbitrary. The team can pick whatever they want. And then they would give a list of servers they want to start. In this case, we have 2 app servers, 2 web servers. And this is a code that we wrote to actually do the heavy lifting. So we know which VPC we want to use. In this example, we're using the default one, but that would be one that was created externally. We have a default AMI that also has all the bootstrapping software on there, and we pass that to the instance. And you can see here that we get that list of names passed into the construct, and then we just loop over them and create one EC2 instance for every name. The final thing that we actually have to put in there is which availability zone they go into. And for that, we do a little trick, because we don't want them all to go into the same subnet or the same availability zone. And that's what actually would happen if you have them all in the same stack, because the CDK will pick always the same availability zone. So we want to have them spread out over availability zones for 2 reasons. If they're creating app 1 and app 2, we want to have them spread out, so we have high availability there, because it might be putting that in a load balancer later on in the stack. And also because if we wouldn't do that, then all the instances would end up in the same subnet. We would run out of IPs in that subnet, while the other 1 or 2 subnets would be still empty. So that's the reason that we wrote this code like this, and this is what we're using as our construct. And if we synth and deploy our stack, this is the YAML output that would get passed to CloudFormation, or at least part of it. I hit most of the other properties to make it fit here. And you can see that we create 2 sets of 2 servers. We have the 2 app servers at the top, the 2 web servers at the bottom, and we go A, B, C, A, spread out over our 3 availability zones. And that all worked great, so far so good. We've successfully finished the migration. We hit that deadline. Everything is running in the cloud, and we can start working on improving our apps, making more apps. Maybe we'll actually start using more serverless things. But at some point, a few months later, we actually realized, oh, actually we can improve this app as well. We maybe added some database servers, and at some point we want to connect to those servers directly, and we need a Bastion instance. So we do exactly that. We open up our old CDK code. We add our Bastion to the instance group. And because we know our ABCs and we like to have things neat, we put Bastion in between app2 and web1. And our constructor works exactly as we expect. So we go from this old output to this new output. And here we see our Bastion instance appears in the middle of that. There's one problem. That's not the only thing that has changed. So because we added that in the middle and we're looping over our instances, we also changed the availability zones. And that's a problem, because changing availability zones means a recreation of the instance. And it's a hard problem because it's not easy to spot. From the consumer side of things, from the teams using our construct, they didn't really change anything related to those instances. So they don't really expect something to change. They think it's a very low risk change because they only added one server that's independent of everything else. And from our construct's point of view, there's also nothing strange going on, because if we're testing that code, and as long as the inputs stay the same, our outputs don't change, and it does the looping over the availabilities correctly, and we're saving the list of availability zones in our context file. So all of those things don't change, but still we get that that shift in availability zones. And the only actual realistic place to spot this is in the CloudFormation change sets. And that's hoping that we're actually checking that, which was the case in this story. And that the person checking that actually understands that an instance replacement is something that they don't want. If you don't spot it there, then it's hopefully your staging environment that sees those replacements and not your production environment. We did get to learn from this, so that's the real reason from this talk, of course. I'm not just talking about my mistakes. I also want to explain which lessons I'm taking from them. This one is not really actionable, but it's sometimes a good indication if you think you're being clever, there might be something you're missing. The real lesson from this story, on the other hand, is to have a way to build mechanical sympathy. It's very important to build that into your abstractions and have teams be able to learn how they behave behind the scenes. So what is mechanical sympathy? It's the idea that you can never be successful if everything is 100% invisible to you. The typical example of that is that you don't need to be a mechanic to be a Formula One pilot, but you need to have a general idea of the things that are happening under the hood, so that you know how the car will react in certain situations, that you know what to listen to if the engine starts making strange noise, and that you actually have some early feedback if you're pushing your ar to do things it wasn't meant to do. If you don't have that mechanical sympathy, you will miss that. And if we write a construct that doesn't expose things that the user of that construct should or might care about, we're actually setting them up for failure, because they will miss all those early warnings and they will not have an intuitive understanding of what we're actually creating. So a better way that we could have done this, for example, was to, instead of creating a construct, creating some examples showing what are all the things we need if we set up an EC2 instance, and then have the teams put in the level 2 constructs directly in their code. Or maybe build a level 3 construct around a single instance, so that they can use that we don't have that loop, and that we can much more easily expose all those things that they actually should care about that might trigger a replacement. So things like the AMI, the availability zone, the subnets, maybe security groups. We want to surface that so that it's not a black box for the teams using it. Another story that I wanted to talk about, and this has multiple mistakes, spoiler alert, is to do with custom resources. So sometimes you might find that the resource that you want to create in your AWS account is not supported by a level 1 resource. And because it's not supported by a level 1 resource, there will also be no level 2 or level 3 resource. And there can be multiple reasons for that. It might not be supported in CloudFormation itself. You might want to create a resource that actually doesn't live inside of AWS. Like I know that Benki, who once made his hue lights turn on and off with CloudFormation. So if you want to do something like that, that might also be a reason that there's no resource for that. And in both those cases, you can still manage those inside your CloudFormation stack if you write a bit of glue code yourself. And I'm going to do that with an example here. And in that example, I'm going to assume that there isn't a custom resource, that there isn't a resource yet for the SSM parameter store parameters. I know they are, but it's a very good example just to go through all the actions you would take to create such a custom resource. So this is the full code of what that would look like, or could look like. And if you look at the top right here, you see that if we use that in our stack, it's almost the same as using that level 1 or level 2 resource directly. We're giving it a name or an ID, and then we say the name of the parameter should be test, and the value of the parameter should be something. And then if you look below that, you see the actual implementation of that, and there's a very useful CDK clause that helps us create custom resources, where we say on create, when this gets created in the stack, you should execute this API call. When it gets updated, you should execute this API call. When it gets deleted, this other API call, and so forth. And you can see the API calls on the left above that. It's basically doing SSM put parameter or SSM delete parameter. And that's all we have to write, and CDK will take care of gluing it all together and doing the right API calls. This is the actual rendered out template of that. So you can see that we have our custom resource in here that is of type custom ::AWS, where we have those create, update, and delete actions. What you can't see here is that the rest of the line would have the name and the value in there as well. And then we also see that that service token defines what is the underlying Lambda function that gets executed for that. And that's the one starting with AWS 6.7. So that would actually execute those commands. And then underneath that, we see that we also get some custom resources that are created by the CDK that are used to set that log retention that we specified earlier, because there are some tricky things with CloudWatch logs. And if your log group already exists, you can't put the log rotation on there that easily. So CDK decides that they're going to be using their own custom resource for that. And it's that log thing that's also part of the problem, that and Lambda functions. So if we do it like this, we get those two Lambda functions, those two custom resources for every stack that uses our SSM parameter. So once you start having a little bit of more than one stack and working with multiple teams, that can grow very rapidly. You see here a screenshot. This is just from my testing that resource 7 times. Just create delete 7 times. And this isn't even the full screen of it. That's all the things that stick around after delete. So the log groups, they stay, they stay. Which is not a great thing, because it becomes very hard to start looking for errors. If something goes wrong, you don't really know which log group you need to look. You need to go to the stack, and then from the stack to the Lambda console, and from the Lambda console, open the monitoring tab, and then go back to CloudWatch. So it's not an easy way to keep managing that, because it's never obvious where you want to look. And I already teased a little bit, there's a second mistake in here as well. So let's take a bit of a closer look at what I wrote, especially on this part, maybe even a look that's a little bit closer. You see that I mistyped something. So instead of writing name, I wrote gnome, and that might seem like a very small innocent mistake, and it is, and it's very easy to make, but it has some very annoying effects on our deployed stacks, especially if you're not creating resources that are basically free. If this would create an EMR cluster, for example, and the delete fails, then you might have a very high cost that's not easy to spot until you get a bill. Because this is what the CloudFormation stack will look like after the delete. So we deployed the stack, we clicked in the CloudFormation console on delete stack, and you can see here that the delete was successful for the Lambda functions. But the delete failed for our parameter. And that means that that parameter still exists, but we don't have the code anymore that will be able to retry that delete, because that Lambda function got deleted. So there's no way to automatically clean that up, even if we would try the delete again here. So that's not good. And what makes that even more annoying is that once you notice this in one stack, we'll have to go and update all the stacks that use this custom resource, of course. So now we have to go to all the teams, make sure that they're using the latest versions, that they update their dependencies, that they actually do one more deploy before they delete things. Because if they don't do that, if they do the delete of a parameter together with the updated dependencies, then that won't have any effect, because actually going to delete it first. So it's a very hard problem to solve once it gets deployed in lots of stacks, and it's something you actually can get fairly annoying. We did also learn from this, of course. The main lesson here is that your custom resources are applications, and you should manage them as such. So this means they should have their own stack. You should create them once per account, and you should actually think of them like how you might think of a VPC that's shared between different applications. And that also means you need to do the same things that you would do with them that you would do with other serverless applications. You have to manage metrics and logs. You probably want to create that log group before the function gets created. so you can you don't have to use that custom resource there. And in general, you want to be prepared to keep supporting the application for as long as it sticks around. There are some CloudFormation features that can help here if you do that. So for example, if we're saying we're going to split this up in one central stack and then stacks that use the resources, we can use export in the central stack and import value in all the other stacks. And then we are confident that as long as there's at least one resource that's using that function or that's pointing to that Lambda function, that we can't delete it. So we know that we also always have that function ready to handle deletions. It also gives us a lot more control about updates and log groups and monitoring, because we can do that completely independent of our consumers. So if we find a mistake, or if the underlying API would change and we need to update our Lambda function, we can do that without having to involve any other team, just the team that's responsible for that stack. And also something that's important to keep in mind: if you're creating a construct that creates Lambda functions for somebody else, they become responsible for that Lambda function, and it's important that they know that. And it's also important to be able to have a way to update those functions when needed. Finally, in the theme of using CloudFormation features, there is actually a CloudFormation helper library that can help with some of the boilerplate when implementing your custom resource as a Lambda, because if you put it in a central stack, we can't use that AWS custom resource CDK class anymore. But to be honest, there's a better way to do that. If you need something that would be a custom resource today, and you're not using custom resources yet, or you want to move away from them, the private resource types that were released in, I think, December 2019 are the better option in almost every way. You can basically think of them as custom resources version 2. They're using the same framework that AWS uses to develop the native CloudFormation types, so you also get a lot of the features that native CloudFormation types get. There's one downside, and that is that the initial learning curve is still a bit steep, especially compared to that AWS custom resource that we just did. And there's a lot more information that you can find about how you develop serverless applications compared to how you would write resource providers. But there are also a lot of open source repositories that have resource providers in them. The AWS ones, or some of the AWS ones, are actually open source. And the extra features that you get from building it that way is, in my opinion, definitely worth the investment. And then finally, I still have a few minutes to talk about a third mistake that I made. And this is not going to be any code anymore. It's going to be more of a story. And it's actually going to be about how my typical flow is if I create an abstraction. So that would be a construct in CDK or a module in CloudFormation, how that usually goes. So usually that starts with very good intentions. There is something I can fix. There is a construct or a resource in CloudFormation, and it isn't as easy to use as I think it can be. So I can make things easier, and I can do that either for myself or for somebody else. Doesn't really matter. I see something. Oh, this could use different defaults. Like the settings that I put in here are not the defaults that I want to use, that I want to recommend to people. For example, it's an S3 bucket, and I want to make sure that it always has that public access block enabled, things like that. So that's great. I create a construct for that. I know how to do that. I wrap my S3 bucket inside that. I limit the amount of inputs that I accept. So for example, if I don't want people to be able to set a name for that bucket, I don't allow it. Everything is better. I limit what you can do. This is good, like the default way to do this. Great. Until you get feedback or you start using it more, and there will always be some place where, oh, I actually want to change the name here because I otherwise I get a circular dependency, or we have this one weird edge case where encryption doesn't work, so we need to disable it, and you need to add extra properties to that. That's not a problem. You update construct, you have people update their dependencies. If you're lucky that this happens never or only once, If you're unlucky, you can just keep repeating that cycle until you have every property in there. And even if you have all the properties in there, like the story isn't over yet, sometime later there's a new feature with the construct that you're using or with the service that you're using. They add more properties to that construct. And now we have two imperfect constructs, because both the one that I created with the new defaults is not using that new one yet. And the one that's coming from CloudFormation or from CDK might not be able to use those new defaults, because that would break backwards compatibility. So we follow that same cycle again. And now we also have to be careful about not introducing any breaks in stacks that might already be using the older construct. So that's either being very careful, maybe have like different versions of constructs. Anyway, it gets complicated, and this can repeat as well, of course. And in the end, after certain iterations of either of those things, it gets very muddled and very confusing. Either we forget what defaults are resetting, what defaults are coming from the construct itself, which defaults are coming from the service. And we have to look in the code every time, or we end up with a construct that's basically passing everything. So it's not really an abstraction anymore. It's just a different name for the original level 2 construct. Both of those things will lead to confusion, frustration. It will be hard to know what to use, and it will be even harder to predict what we actually are going to be deploying. So some lessons that we learned from that and from running into that problem a few times. One of them is try not to do it. And instead, well, try not to create abstractions when they are not needed. It's a bit harder to, like, in general, not run into problems. There are some other ways to make sure that you have the right configuration inside your resources that don't require you creating another abstraction that might make things more confusing for people using it, because they won't know, do I have to use that abstracted bucket or do I have to use the default S3 bucket? If you always have them use the default S3 bucket, but have a different tool that then can check the properties, you can have both things. So few ways to do this. Again, you can write example code. That's always a good place to start. If you can highlight, like, these are things that are important, this is a way to configure it. Gives the users a very easy place to start, because they can look at that example code and start using it. Also gives them an easy way to know what they are configuring. So you have that mechanical sympathy in there. And it's a very easy way to break away from that if you would have an edge case where that default wouldn't fit with their use case. Of course, that also depends a bit on whether it's a governance thing or just something that you think should be a default. On top of that, you can use tools like CFN lint, the CloudFormation linter, CFN guard, CFN nag, that can scan out the Synta templates. And they can flag non-compliant resources. So they can either have their own rules, or you can write your rules yourself, and they can say, oh, you're creating an IAM policy that has a wildcard in it, that's not allowed. You're creating an S3 bucket that's not encrypted, that's not allowed. Please fix that. And finally, you can do similar things using the CDK aspects. So you can scan every S3 bucket that gets created inside your CDK code, and then throw an error if it's not following your governance guidelines. And in all these cases, you keep that configuration visible to the person that's actually responsible for that configuration. So you're not doing anything magic, and they will actually know what they're setting up. There might still be places where you actually want to create an abstraction. I'm not saying that abstractions are bad. They have a place, but there are some things that I try to check before I start creating one, and to make sure that they make sense. The first is I should be able to give it a name. A construct named encrypted bucket is much better than a construct named my bucket, even if they do the same thing, because the encrypted bucket is clear. This is going to be encrypted, and you will never have to change that property to non-encrypted, because then it's not an encrypted bucket anymore. On top of that, they should do one thing generally. So it's better to have a construct static website and then a separate construct static website with authentication than to have both constructs and then have conditions in there and selects and if statements that would create confusion about what is the default thing that should be created. And finally, abstractions are hard. It's hard to write good abstractions, and sometimes it's better to be explicit in the stack and use the level 1 and level 2 constructs than to hide a lot of things behind an abstraction that then will leak or cause confusion. And since I'm almost out of time, or actually just out of time, a summary of all the things that I did wrong. I didn't always put in thought about mechanical sympathy. I was too clever. I hid too much. I made mistakes with custom resources, and I should have treated them as separate applications and deployed them like that. CloudFormation features are very nice to use. It's not because we're using CDK that we shouldn't use CloudFormation features, and keeping up with that can actually be an increase of flexibility. And finally, we conclude with a general story about how abstractions are hard. There are also some mistakes that I didn't fit in this talk, mostly because of time. One thing that I want to highlight is every time there's something that has side effects or retrieves states, there is a risk introduced. I have a few stories around that as well. The CDK context.json helps a little bit with that, but just like with the being clever reflex of am I doing the right thing, every time you call an external API, it might be a good moment to reflect, is this actually a thing that I want to do, or is there another way that I can achieve the same thing without having to save state inside of my CDK app? So thank you all for listening. My name is Ben, is still Ben. I will stick around for 9 more minutes for questions and discussions. If you'd like to contact me or Cloudar, all the information is on the screen right now. I will stick around in the chat as well to have more discussions about this and the other things happening on CDK Day. Very shortly about Cloudar. We're a premier AWS consulting partner and an AWS managed service provider. So we can help with anything that's AWS related, and that's from billing to full management of your AWS environment and everything that fits in between that. So thanks again, and I hope hopefully I can see you all soon in the chat.
Yeah, thanks, Ben. Eric, you're muted. Yeah.
Yep. Yeah, I know.
So, oh, yeah. No errors happen. We just learned this. So yeah, thanks for this very interesting topic about mistakes we all make and never think they might happen. Otherwise, it wouldn't be mistakes. So if you have any questions, put it in the chat or in the CDK Dev Slack, and we will be happy to relay them to Ben to see what.
Yeah, I see a question about the I'm just going to dive into the bottom ones that I see because I didn't see the everything before that. I see a question about building the CFN private resource types with CDK. I don't have an example of that handy, but the way I would do it is you can use the CloudFormation CLI that will help you set up your private resource type and define your schema and how it will interact with CloudFormation. And then you can build your own level 1 constructor around that and use it in CloudFormation like that. And since the private resource types are also deployable with CloudFormation, I assume they're also supporting CDK to do the deploy with CDK itself. So you can write it just like you write any other application. Like if you're using, for example, NPM that also has some installers and that might install software, use CloudFormation CLI like that. That will build out the zip, and then you can build that zip and deploy that as an asset inside of CloudFormation.
Yeah, and to elaborate on this, I think yesterday Mauricio added a video how to use L1s for custom resources. So I think if I can find the video link and post it to the Slack.
So there's a statement here by Jean Gazda. Says, one useful advice, don't start implementing CDK in your company by trying to create a framework for your teams. Spend the time teaching the teams how to write good CDK. That's just good advice. Any framework you're using, that's just really good advice. So,
and it's very tempting with the power of the CDK to say, oh, what I'm going to do is I'm going to write a massive amount of constructs to fill like every use case. And like I completely agree with that. Instead of doing that, just write one simple example of using the level 1, level 2 constructs, and then go to the teams and explain what that's doing, because they will be managing not only the CDK code, which you can simplify, but they will be responsible for everything running in the cloud as well. And if you simplify that and hide that away, then you're just making it harder for them instead of easier.
That's right. That's right. We had a question out here from Brian, and I don't think you'll be able to cover all this, but do you have any good resources? Can you provide an overview of all the CFN options, custom resource, private types, modules, macros? Ben, go.
Yes. So if you need something custom, first thing that you should look at, custom resources. The private types. If you can use a private type, use a private type. There are some use cases where they might not fit yet. In that case, you can go for custom resources. And those are like, I want to create a thing. So a resource is part of that. The other things that exist are modules, and that's very similar to CDK constructs. So that's, I have a group of things and I want to give them a simple name. For example, that might be also a way to work together between teams using SAM and teams using CDK, is that you can create a CloudFormation module that both teams can use. And then you also have macros, and macros are sometimes a bit tricky because they actually introduce some more variance inside of your templates. So macros run before the template gets deployed, but inside of CloudFormation. So you write a Lambda function that gets the template passed to it, can do any transformation with it, returns another template. You can verify that the template that it's created is correct. And then you can say deploy this template. So it's somewhere in between that. Again, if you can avoid macros, it's probably better, because they, just like introducing the external state in your CDK app, they introduce a certain amount of uncertainty and risk, because now you're running custom code. Just like you're running custom code in your CDK, or might be running custom code in your CDK, if you're not just using the constructs, but you're putting ifs and loops in there. Every line of code that you write is a chance of making a mistake. So if you can avoid writing pieces of code and you can fix it another way by, for example, using resource types or by restructuring your templates, that's probably a better way to go about it.
I've always said the most brittle part of an application is my code. That's
yeah,
where
exactly.
it's introduced. Yeah. So I have another question here. It says, what is best practice in using one level 1 CFN constructors or 2 level 2 constructors?
I'm going to leave this to the CDK experts. I'm personally a little more versed in CloudFormation, but I assume if the level 2 construct is stable, I would use those. If they're unstable, I would stick with the level 1 ones. Just because
that applies to anything. If it works, use it. If it doesn't, don't use it.
But no, it's not if it works. If the chance, like the hard thing about constructs, whether you write them or the level 2 constructs, is that it's very hard to predict what will change. For example, if you look at the GP2 and 3 volumes, if you have a level 2 construct that would be creating a disk by default, and it's creating it with GP2 right now, even though CloudFormation might be still creating GP1. And that will switch to GP3 at some point, maybe. That doesn't really matter who's writing that resource. That introduces a risk, because that, depending how that's configured, might be an instance replacement. And the risk of that happening with level 1 constructs is very low, because CloudFormation guarantees if the template works right now, it's going to keep working. That's the API is stable. For the level 2 constructs, there are levels of stability, and there's like a lot of effort put in there to not break things. But every time you update dependencies, you will have to check whether there are actually changes there or not. Yeah, I would use level 2 if possible. You can see on the CDK website, if they're still experimental, in that case, probably avoid it for production apps that are hard to recreate. But if they're stable there, I would probably use the level 2 ones, because otherwise there's not a lot of, well, there's still some added value in CDK, but you lose a lot of the value there.
Yeah. Perfect. And there was one more question. Maybe you can answer it on CDK Slack, because we are out of time. but you were tagged in it. So with this, thanks, Ben, for